Welcome everybody to week 15. So today we will finish off our discussion of the rendering pipeline. We've talked before about data structures to like how you know where a line hits something. Like we did that before, right? Will you? Right? Like if you're doing a trace line, we have like bounding volume hierarchies or quad trees or binary space partitions that allow us to quickly determine intersection of rays and objects in the world. So for the view projection, like I said last time, the requirement is just for a very simple, what is this, a camera? What kind of camera is this? It's a camera, okay. So the most basic thing that I can think of is you got your x-axis here, you got the y-axis here, this is the screen basically, think of it that way. And then down the z-axis, the camera is looking. That's how you had your setup, right, Mulia? You had your camera staring down the z-axis.
On the z.
Yeah, and so there's something called like normalized screen coordinates or something like that. Screen normalized coordinates.
Yeah.
Yeah, and so
you have
that
to divide by w.
Yes, that puts a 0, 0. At the center of the screen, the bottom right corner is 1, 1. This would be 1, 0, or 1, negative 1, rather. This would be negative 1, negative 1, and this would be negative 1, 1. Right, and so normalized screen coordinates are nice because the way we normally do coordinates on the screen, right, is we have, this is 0, 0, right, when we're actually rasterizing pixels. We have a column, which is x, we have a row, which is y, and so if we've got a 100 rows and 200 columns, then this is 0, 0, and this is 99, 199, right? But if you change resolutions and things like that, then things kind of break. And so mathematically speaking, we typically use what are called normalized screen coordinates. And the reason why we do this is, like, let's say we're going to do a triangle out here in the world. Let's say this guy is straight ahead of us, like right in the middle of the screen. Then that's going to project onto this right at 0, 0. And then we can convert from this into, okay, whatever the size of the x is, whatever the size of the y is, divided by 2, and draw a pixel there, right? And so what we do with this is, let's say we've got a 90-degree field of view, just to keep things simple. Let's say that we are, let's say our screen, the near clipping plane is 1 meter away from us. So it's 1 meter away in the z depth. That's where our near clipping plane is, and that's where we're going to be projecting the images from the screen on. Let's say that this guy is 2 meters away. Okay. Let's say this triangle is 2 meters away. This guy's right in the middle of the screen, doesn't matter. But this guy here is, let's say he is 10 units to the left of the center. And this corner here is 10 units to the right of the center. And this guy is 2 meters away from us. And so within, so that's kind of like on an orthogonal projection. Let's look down at it from above. So if you have a camera this way, and you've got a screen that is 1 meter away, then a triangle that is 2 meters away, the triangle for the field of view is twice as wide here as it is here, right? So if this is like x units, this is like 2x units, right? That makes sense? William?
Yeah.
And so if we are, 10 units right of, if we are 10 units right of the center line, like that point up here, then we just divide by 2. We divide by however far away this is. So 2 meters divided by 1 meter is 2. And so we're going to just divide the x and the y locations by 2. So the x location on the projection is just going to be x divided by, in this case z, right? Because z is 2 meters away. And the y location is going to be y divided by z. And that's it. That's how you project from a triangle in 3D space to a screen with a 90-degree field of view. If you don't have a 90-degree field of view, then this number is actually going to be, going to have a little bit of trig in there, right? It's like if you have a narrower field of view, then it's going to be, what is that, the cosine?
So wait, with a 90-degree field of view, you're essentially doing orthogonal orthogonal projection?
No.
Isn't that
No,
how
it's perspective. Because the further away something is, the smaller it's going to get. Right? Orthogonal is not a view frustum, whatever. Orthogonal is like this, right? And so if you have a triangle out there,
it's just like you're casting a shadow.
yeah, it just hits the screen wherever it is in the world. It just hits the screen there. That's what we did last time with screen space coordinates. For an orthogonal projection, it's just wherever they are in the world. We clip them if they're outside of the boundary, right? If they're over here, we clip them out. But otherwise, wherever the triangle is, it just appears on the screen when we project it at that location. When you're doing a projection like this, which it has perspective, right? The further something away something is, the smaller it gets, right? And that's what causes us to see, like when you're looking down a corridor. Oh, geez. Right. Let's say you have two triangles that are both the same size, right? One is near you and one is far away from you. This far away one's going to be smaller, right? Do you see that?
Yeah.
And if one's even further away, so it's the same triangle drawn 3 times but further away. What happens is they shrink, and that's what gives the illusion of depth. The human eye perceives depth via size, right? And so, like, once I saw a model plane flying up in the sky, I'm like, oh, look at that airliner, and then it dipped down below the trees, and I'm like, oh wait, that's just a model plane, because it looked like a real plane, up in the sky. I'm like, oh, look at that, look at that plane, and it goes, and I'm like, oh wait, it's this big. It's not. It's not a giant plane up in the sky, because we use size to determine depth and things like that. And so with a 90-degree field of view, which is the easiest one possible, and again, always start easy, and then if you want to shrink the field of view, you're going to use was it a cosine?
It's
Sine.
I have the actual view to projection. It has to do with the aspect ratio. This one actually doesn't use. Oh no, it does use trig. It's so.
Yeah, you'd also divide by the screen, right? Whatever the width of the screen is, like if it's 1080 pixels wide, then this guy would be 10 divided by 1080, right? As well as the distance.
Okay.
And so, yeah. But that's why we don't use that when you're talking about normalized screen coordinates. You don't need to worry about that. You start off just by worrying about depth, right? And a very simple 90-degree field of view, it's very, very easy. The X and the Y location, where Z, it's like if you've got, let's look straight ahead. If you've got a triangle that is at, one of the pixels is at 1010, let's say, 1010.2, then it's actually going to be rendered at 5.5, right? And if it was at 1010.4, then it'd be rendered at 2.5, 2.5. Because the further away it is, the thing scales down. That makes sense? So the actual X and the Y location are just divided by Z for a 90-degree field of view.
And that's assuming 90 degrees both directions, right? Like
no, it's 45 in both directions.
It's
45 this way and 45 this way.
No, I mean, like, because we're looking down on the frustum, right?
Yeah, the camera's here. The camera's here, looking this way.
So yeah, so I mean, like, if we look vertical, like, let's say we were looking in the view of the camera, like, we would have a horizontal FOV of 90 and a vertical FOV of 90.
Correct, but you can adjust for that again with the aspect ratio and things like that. So you would also the number, like the number of pixels to the right it is, gets scaled by the number of pixels on your screen resolution, and you would have one of those for X, and one of them for freeze, and one of them for Y, right? So you can have an aspect ratio factored in, and it's just a different number you divide by. But yeah, so if you have like 500 pixels vertical, then you divide by 500 essentially to find out how high up on the screen you are, right? So yeah, and so with a 45-degree triangle, then the distance they are away, Z, is equal to how much you need to scale them towards the center. Does that make sense? Mm-hmm. So it's just yeah, that's literally it. Like, that's where I would start with a projection algorithm. Just take your orthogonal code and just divide by the depth, and And you'll find the further things are away, the more they shrink towards the center of the screen. And if they're off to the side, then all the triangles shrink towards the center of the screen, and they get smaller also. Is that right?
All right, because orthogonal code is basically just taking up the z and then just plopping it on the screen.
Right. Yeah. So as a quarter goes this way, in an orthogonal projection, you won't even see it, right? Like let's say you're in a quarter that's like this. You wouldn't even see these lines, right? Because you're like the orthogonal. You have a God's eye view. That's every pixel you're looking down the thing. If these are a plane, you wouldn't even see them. But in a perspective view, what happens is that you get. Let's see if I can draw it better this time. You get the vanishing point, right?
Yeah.
So if you're
everything converges to the center.
Yeah, and that's just this. That's it. That's for the absolute simplest thing, and then you can add in like the aspect ratio, and you can add in different fields of view. And I can't remember off the top of my head if it's a sine or a cosine or something like that. But you can adjust the field of view. You can adjust the aspect ratio, and basically that's about all there is to that. If you want to move the camera around, like if you want to translate the camera this way, 5 in the x direction, then what that has the effect of doing is moving all the objects in the world 5 left, right? So as I move my head this way, it's effectively, Einstein relativity, right? Me moving my head to the right is the same thing as if the entire universe moved to the left, right? And so for the camera, you typically have a transformation matrix, right, of some sort. Starting off with identity, and then you're going to layer on, translations, rotations, probably not scaling. It doesn't make a whole lot of sense to me to scale a camera. Yeah, probably just translations and rotations. And then what you do is if this is M, you compute the inverse, right? And so for every object in the world, you run it through the inverse of the camera's transformation matrix, right? So instead of the camera moving 5 to the right, effectively you're moving the entire world 5 to the left. That makes sense? Yeah. And so you can just move the camera around and the world will slide around and stuff like that. And the world's not actually moving. It's just they're all getting transformed by the inverse of the camera. And that's it. That's really all there is to that. At least at the simplest level. Like I said, you can slap more details on it. How would you do scaling? I don't know if that makes sense. Shrinking I don't know. There's probably something you can do with it. Like mathy people have got like all sorts of cool tricks and stuff like that. And it's always interesting going to like SIGGRAPH and just sitting in on these talks about these people who've come up with a cool new mathematical technique to do something or other, and it's like, oh, that's neat.
Oh.
So
I think I just realized what was
wrong with your code?
What was wrong with all of my stuff, because I noticed that the mesh that was created is touching the origin. Which, when it's thrown into the far plane calculation, you're basically saying it's touching the camera's lens. At least one of the corners.
Yeah, you should have a near clipping plane, right? For that reason.
Yeah, I do.
So is it getting clipped away by it then?
Well, no, because I don't have any actual culling for that. But what's happening is basically that one corner of the cube is just right up to the lens, which is why everything's just converging to the bottom left of the screen.
Okay, all right. Yeah, I'd probably put in a near clipping plane and a far clipping plane. So the far clipping plane would be over here, and the near clipping plane is oftentimes the same plane you project onto. Do you guys know how projections work in 2D space? Just to maybe go even a step simpler. Like a shadow. Let's say we've got an x-axis. Something's vibrating. Let's say we've got X here. And we've got some object up here. And we want to cast a shadow on this. That's projection, right? The whole axis is kind of rotated a little bit. Whatever. It doesn't matter. It's a basis vector. It's an orthogonal basis vector in 2D space. Basis vectors are like what you combine together to find locations in space, right? So like this guy might be 5 in this direction and 4 in this direction, so we call that 5, 4, and that means 5 times the x-axis plus 4 times the y-axis. And so we have world space, which uses the worlds x, y, and z, but we also oftentimes have local space where we've got forward and up and right. And so we could also give locations in space by saying this is 3 times forward plus 2 times right, or things like that. And so you can have different basis vectors to refer to the same point in space. And a lot of times it's just more convenient to use like these, like if you're making a bullet or a gun or something like that, or a laser or something. A lot of times we use these basis vectors, forward, up, and right. Sometimes we use the worlds, x, y, z. You know, they're orthogonal, which means they're at 90 degrees to each other. You can theoretically have basis vectors that are non-orthogonal, and it just makes everything more complicated though. So, so we don't use this very often. I mean, I shouldn't say that, but yeah. Anyway, so we're talking about projection, right? So we could actually make this horizontal. Come on. There we go. So here is the surface of the Earth. Yeah, X. And we've got a diamond up here. This is our object. And the sun is overhead, and we want to know where the shadow should be cast on this plane. Okay. You guys understand?
Yeah.
Okay. So, basically, let's see, this is dot product. So we take the dot product, let's see, we have the sun, which is this way. Actually, if it's, I mean, for a vertical thing, it's like quite easy. Let's maybe do a shadow coming this way. Right. And so, let's see here. And so a dot product is literally a projection. So if you've got, and this is for non-normalized dot products, right? So if we got one vector here, and we've got a vector here, when you dot product x and y, oops, I just made my face bigger. Whoa, what just happened here? Ah! I'm growing out of control. What the heck is happening here? Weird. Yeah, so dot product is literally the answer that it gives you is the point that this tip here is going to project onto this point here. Okay. What we typically do in casting shadows, though, is it'll create what's called a shadow volume. Well, I shouldn't say typically. There's a lot of different approaches to doing shadows. You can do dynamic shadows, you can pre-bake shadows, but there's a few different ways of doing it. And so let's say we've got a surface. Let's actually not make it X anymore. Let's make it actually like a little rough surface, right? It's got this like diamond-shaped box here. We've got a sun here that's casting sunlight like this. We've got some sort of, rough terrain in 3D. Okay. So we've got the sun and we've got this. And so the first thing that we do is we compute the silhouette of the box. So you can compute the silhouette of the box. There's a very clever algorithm that will give you the edges of the box. Like let's say you're staring at a tennis ball. It'll give you this. It'll give you the outline. Basically, all internal. Remember how you did a whole calculation? What you can do is every time you're processing, you got like a triangular mesh here. You can basically say, is this point interior to some other point? And by doing that, and this works from any angle. Like you can do this from any angle. What you do is you essentially could say you've got all these different triangles in here. Is this interior to the hole? Essentially, it's a hole calculation. And so you compute this hole in 2D. It's a 2D hole. You project the thing onto the light, essentially compute the 2D hole. And then once you got an outline of the object, you can project that object's outline out into space like this. So do you guys understand that? Like, it's actually pretty easy to get the outline of an object, right? You can just take all these things, project them onto 2D space. Like if you can imagine there's a screen here, right? And it's looking at some tennis ball. Let's make this a tennis ball now. And so all of these points just project onto the surface. So these are all the different vertices. You got some mesh, right? And so that first homework assignment we did with the hole calculation, you can use it to find out, okay, this guy is to the left, or let's see, if we do a clockwise hole, this guy's internal, this guy's internal, this guy's internal, this guy's internal, that guy's on an edge, that guy's on an edge. And so you can compute the outline of this tennis ball. Okay? And that's a 2D shape. And then what you do is you create a volume that is essentially, how do you make a volume? You take this shape and you toss it out a kilometer, whatever you want your maximum shadow distance to be. You just take that shape and make it 1,000 times bigger, right? And send it off into the distance, whatever max distance you want the shadows to work. It's the same shape. Whatever hole this is, you take that circle and you project it out a kilometer. And this creates a 3D mesh, like a cone, right? So it's going to actually create a cone that is the shadow. And then for every point within the train, you can say, is this object within this shape? Yes or no. And if it is, it doesn't get any sunlight. If it's not, it gets sunlight. And so you can use this is called a shadow volume technique. And so you make a hole, the outline, and then you take the same outline, you just scale it up 1,000 times and push it 1,000 distance off, and then you do a series of point contents, right? Remember how we talked about that before? Is something within something else? And this is like a 3D hole, and you can pretty easily tell if it's inside or outside by doing a hole calculation. Again, it's a hole. That's why I went over that. It just comes up all over the place. You can very easily tell, is this point within this cylinder looking thing, except it's a projected cylinder? Are all the triangles pointing towards it, or is it pointed away from it? And so you can pre-compute for the landscape, if the sun doesn't move, if this object doesn't move, and the landscape doesn't move, you can compute to very fine detail which parts get light and which parts do not get light. Okay, and then you save that into something called a shadow map. Okay. And so basically you write down, yep, this is getting 100% light from the sun. This one here is like right on the boundary, so maybe that spot is 50% lit, and then these guys are 0% lit. So if you go into Unreal Engine and you say pre-calculate shadows, that's why objects in Unreal Engine are listed as either static or movable or dynamic, right? Or yeah, whatever. Static means they can't move. If you have a static light and a static object, you can compute static shadows for it. And so you can sit there, and sometimes pre-computing shadows will take a day. Like it could take a really long time because it goes through every single point on here, and there's a quality, right? Like when you launch. Let me just show you guys. But do you guys see how like math and like what we did earlier with holes and like video games, like they all connect like this, like they. Like I don't get why some colleges don't teach this computational geometry stuff, because it's literally life. It's life itself when it comes to video games. Like I don't know how you can not do it. There are other approaches for doing shadows, right? It's like if you have a box and a sun, something like this, what you could do is say, okay, if this spot is lit, you can travel this way until this area is lit. You travel until you cross over a boundary. This area is not lit. you travel until you cross over a boundary again, and that area is lit. So that's another way that some games do lighting, where they, yeah. And so if you have another light volume like that, then that's lit. You know, I don't know. It gets complicated when there's multiple lights, but basically for each volume, and so this one might have 50% lighting because it is lit by this person but not lit by this person, and so you basically just travel, and you can do this intersection test really easily. See, am I inside? Am I not inside? And so, yeah. So shadowing. It's easy in theory. In practice, when you get things like floating point rounding errors, then things can get dicey. Like, you could feasibly be right on the edge, right? And so your camera, like, what if you're standing right here, right? Your camera might round one way and it's pitch black, then it rounds the other way and it's fully lit, then it rounds the other way and it's pitch black, and the screen starts flashing, and your bloom is going out of control because the lighting is going full intensity and no intensity, and so there's like edge issues like that get really annoying to deal with. And what if you have a really narrow shadow and your shadow map doesn't have enough resolution to hold it, and if your shadow map in general doesn't have enough resolution, you end up getting these like stair step shadows in the game. We were actually looking at that yesterday. It's very common to precompute lighting for this reason, because it's an annoying thing to do. It's an annoying and expensive computation. So you want to keep the number of dynamic moving lights you have to a minimum if you care about frame rate, and you keep the number of dynamic objects to a minimum if you care about frame rate, because you have to multiply all the lights times all the moving objects every frame to do these shadow volume calculations, and that gets expensive. Like, I've seen engines before where like they limit the number of dynamic lights to like 9 or something like that, and if you try having any more than 9 dynamic lights, the extra lights just don't draw and they just vanish, and it looks really, really bad. And so everything else has to be baked. Everything else has to be pre-computed. So if we come over here and go to bat 7K, bat 7. Let's see if this one. It doesn't look bad. Kind of looks bad. So you see these shadows here? Do you guys see that? See the like stair step pattern on the shadows? See that right there? That's because these shadow maps don't have a lot of resolution. And so, like here, you can see if the shadow map had better resolution, the shadows will look better. But that requires more memory, right? And the more memory it requires, your GPU will start crying after a certain point if you run out of memory. And so that's why games usually have shadow quality sliders, is because you really want to know how much. Yeah, you see right there? You guys see that right on the screen right there? How that post there is casting a shadow. You can see like this zigzag pattern coming off of it, and it looks really bad. It's not the fault of the pre-render. It's just the shadow maps have really low resolution. And, maybe it's defensible because this was made 20 years ago, but, nowadays it looks kind of bad. Newest Path of Building patch. Oh, no. One of my former students is a contributor to Path of Building, which is the Path of Exile building tool. It's a really cool tool. Posting stuff. Okay. So what do you guys think so far? I'm not hearing anything from you on Discord.
It's very cool.
Like how shadows work, or?
Yeah. And I'm excited to work on that eventually. It's just.
And probably not enough time left in this semester. I kind of want to get to ray tracing. I kind of want to make a ray tracer. We've been doing rasterization. Maybe we can do ray tracing as your final computational geometry thing. Also, I kind of promised the Berkeley people I would use their stuff or something, so maybe I'll have you guys do data science. I don't know. What do you think?
Oh, JT is talking about he wanted to show our project because we thought we were actually going to be doing presentations instead of just posting pictures.
Yeah, okay. Let me just... Where is it? Paint. It's a little bit big. Okay, so you see where it says lighting needs to be rebuilt. So I've messed around with the landscaping a little bit, and so now lighting needs to be rebuilt. You see how there's shadows here? I cut away. Let's see, did that work? Yeah. See, I'm cutting away the landscaping, but the shadows from the landscape remain. Right? And so that's actually a pretty nice detailed shadow map. Like even if I zoom in, like if I get really close, you can see that there's some banding there. That's a pretty good shadow map, right? So if I come up here and go to build lighting quality, it's set on medium detail. If I were to build this with production quality, what that means is that how many pixels are in the shadow map mostly, right? Light map density rendering. All right, so let's see if I can move this out of the way of my face. Build lighting quality, production, lighting info. Let's see, lighting resolution, DSP surfaces 1 to 5. Let's see if that shows up here. Yeah, I don't know if it shows up here. But yeah, okay. So this is the lighting info for the level, and you can see how much light map memory these things are taking up, and so if you do really high quality shadow maps, that can eat up a lot of the memory on your graphics card, just loading which spots should be shadowed and which ones shouldn't be. But we do it anyway because doing this in real time can be very, very painful, and it can really tank your frame rate. So yeah, I'm not going to rebuild the lighting now. But the last time I did it in high quality, I might as well save it. The last time I did it in high quality, then it took like overnight to run, and that's not even a big level. It's got a giant landscape. Right? Okay, so okay, I do have one other thing I want to talk about today, but yeah, let's see your stuff. Let's see what you got. So JT, you wanna stream your thing, and we'll put it up on the big board and put it up on YouTube for posterity.
Yeah. Go ahead and also I sent you a zip, a Google Drive link to a zip, so you can connect as well.
Windows no editor. So how many viruses are in this, JT?
How many can your computer handle?
7.
One more than that.
Google Drive can't scan this file for viruses.
Yeah. It's gonna complain.
You're just filling me with confidence right here.
It won't even let you run it unless you give it specific access.
Yeah.
That's funny.
Just invite the virus in. It's fine, I swear.
I'll run in a virtual box.
Okay. You want me to share my screen?
Or, I mean, if I'm going to connect to it, then I guess you don't need to. Give me a few more minutes.
Oh, yeah. It's easier if you just connect.
Yeah.
And
then, all right.
And then it'll throw an error probably. Just hit OK through that. Like a CDO constructor. It's for a plugin that we have to remove. It's basically complaining that the client that compiled it didn't pay for the plugin because I got it from Walker.
Gotcha.
Oh my god.
Are you in here, JT?
Yeah, I'm in here. I'm bottom left
Oh,
side.
there you are. There you go.
Hey, take it easy there, champ.
So you got a pack file?
Yeah, this was only... the timeliness of compiling all this was only because I got a school laptop. Oh my god, packaging takes so long.
Yeah, it does.
Especially with source engine, or with the source build of the engine.
Okay, can I switch? I can't switch screens. So let me go into Discord and pop that over to screen 1. Change windows.
Yeah, it only starts in full screen.
Windows no editor. Okay. Join server.
You're streaming the file explorer.
Am I? Okay.
Yeah.
I thought I picked
The actual executable is called TDPPV.
There it is.
How about now? Am I streaming it right?
There
Yep.
you go.
Okay.
Yeah.
Yeah, your bottom left one. So it's WASD. If you hold right click,
Whoa. What just happened?
that's
I just
Luya killing you. If you hold right click, you like walk around. It's like kind of twin stick shooter controls on keyboard and mouse. And then left click is the line traces for the firing right now. Oh, someone killed me. Yeah, so the weird screen it gives you is the default spectator screen from the engine. That's just something we haven't added onto yet. We're trying to build this one character out as much as possible on the back end, so that it's very easy and expose as much to the editor as possible, so it's very easy to just blueprint, drag and drop.
I think Mui is spawn camping me.
Yeah, he definitely is.
Oh, he's on a vengeance.
This is our
Good thing I can
right
screen
now.
peek.
The immediate next thing that we're dealing with is cleanup of all the dead bodies, because all of these dead bodies are from last night when we were trying. The server holds its own instance of everything, even if you turn everything off. It's not like cached. It's like
Right.
the server's technically a player with no visuals rendered at all. And the join server button I basically hard coded so that you just join me, like you connect to my computer.
So the direction that I click doesn't seem to matter.
Right click. Hold right click to aim.
I see.
Yeah, it's
If you click otherwise,
harder
it's
to it's just like a weird shotgun.
We're gonna have
immediately kill you.
we're gonna have it so when you're not aiming, you have like a lot more spread, but you have like more mobility, of course, because when you're aiming, you're a lot slower. So we're gonna have kind of characters focused on like running.
Yeah, that's cool. Obviously, you're gonna need graphics for the shooting and sound as well.
Yeah, that's all on the to-do list. Like
That
that's
looks,
this is the clean getting all the server stuff working build.
and
That was
replication.
most of what we put our time into.
Sure, yeah, and then just make a array of corpses is one way of doing it, and make it a circular array.
Yeah.
And that's pretty easy, because then when you die, you toss the corpse into the circular array, and then when you get to the end, you go back to the beginning, and that overwrites the old corpse. And
Oh, yeah. Oh, that's actually.
There's even on the server side, there's a lot of things to do, because technically, like, have you ever started up the server stuff, Kearney?
no, not for dedicated.
So basically, it's literally like you add a -log parameter to launching the exe, and what comes up looks like a server console, but it's literally just a window that prints out log stuff. There's no standard in anything. And there's also like no documentation on getting anything to work with like entering commands and such, because I'm trying to develop it in such a way that I can drop it in a Dockerized container on a server software what's it called, server management software, so I can just automatically spin them up. But it's not actually a server. It doesn't take commands, so
It doesn't. Yeah, having a console to run a server is really nice, right? Where you have something like this, where you just be like, let's
Actually
switch
do
maps,
custom
let's kick
stuff.
people, that kind of stuff. Yeah. I haven't played around with a dedicated server on Unreal Engine, so
It's bad when the most recommended thing to do is to make a third-party software to send RC or like Archon messages to it.
Mm-hmm.
It's like, but why?
Well, I mean, if you guys want, if you add that to, because the Unreal Engine code base is all public, right?
Mm-hmm.
Free and open source.
We found a plugin from 5 years ago that's like really bare bones. That we're going to be adding. We're removing 2 of the bad plugins, like the one that gave you an error when you started up. Our next compile, and then we're adding the server stuff that looks like a bunch of base utilities, and then trying to build that out from there.
I mean, if you guys want to submit that to the Epic GitHub, like I'd give you an A in the class if they accept it.
That'd be dope. That'd be really dope. Because I really want to. At the very least, I need something that accepts a stop command. Because, well, I could show you real quick, to explain better what I'm talking about.
Are you streaming?
I will stream right now. I just needed to pull the important login information off of my screen before I did that.
Your
share screen.
Archon
So
password.
this is dashboard break. Go ahead. Okay, so this is the interface that all my modded network stuff, as well as what's it called? There's a Valheim server here, but this is the web interface for. I guess this is also a Discord bot, but effectively you click on one of these, it has its stats that are running out, right?
Mm-hmm.
And then you can type a command in here, and these buttons need to be bound to specific commands. That makes sense, at the very least. So when you're like actually in the admin console making they're called nests basically. So you have like a nest for Source Engine, which I think is probably going to be the easiest one to build off of.
Okay.
But like Minecraft, Source Engine, and within these nests they have different what they call eggs, and these are all custom
Mods.
configurations
Oh, I see.
to like, hey, I want a vanilla server real quick. I have an egg for that. I'm gonna send a pterodactyl command, which is the name of this software, to the application, and it's just gonna spin one up.
Nice.
Right. So I want to get that dynamically working because that would be way nicer than having to run off of my laptop.
Are they ending vanilla Minecraft?
Okay,
No.
so Microsoft is trying to kill Java as much as possible by just not supporting it as much as their version, because they redid the game in C++ whenever they bought it, and with that they added, I wouldn't say better, they added like a microtransaction system. Basically you have to get like mine coins to buy skins and
In that way, it's worse.
maps and stuff like that, and that's like their marketplace thing that they laid on top of it for all these things that were just for free in Java because you could just implement them yourself. They don't really support modding stuff, even though the modding community is huge. It's painful.
They got rid of modding in Minecraft?
Well, their version just doesn't have it. They haven't said whether they're going to add it, which they better, or else, throw hands.
It's painful in general.
Yeah, that's the unfortunate direction that the game industry is moving, which has been to offer less and less support for modding, or if they do allow modding, to do it in very constrained and annoyingly limited ways, right?
Exactly, and how limited it is hurts the overall, like, what would you say, like the culture of modding in general, because I found, at least in modding in Minecraft, a lot of the people who are like big modders they're all like self-taught, and it's very evident that they're self-taught because they're not using the right type of like data structures to do things. They like really like CSCI 40 and 41 level mistakes are in these huge, really well fleshed out mods. It's like that was the biggest opportunity I had when I was actually when modded Minecraft was actually active, was being able to like message people and I'd be like, hey, this doesn't work, please give me a new build. Like, I have like 30 people on this server being like, yeah, this crashes every time I use it. I'm like, okay, well, I'll go ship that off and get a fresh build and such. But it's just dead now. Like, and even though these servers are dead, like this Project Ozone, which is a mod pack, I don't think, I can tell you, there are 2 people on this server, and it's constantly like jumping up to 400% CPU usage.
Hmm.
It's like, why is this a thing?
Hmm.
They just die. It's like, it's not the server. I promise you it's not the server. It's like how crappily the mods are put together.
Hmm.
So I don't know. It's just disappointing.
100% CPU utilization on Minecraft.
Yep.
2 people.
Gets bad.
Yeah.
It gets real bad.
Huh.
And that's just on that server. On the whole network, because this is the shell that everyone connects through.
Who pays for the CPU time?
This is a box that is hosted out of my friend's apartment in Virginia. He does networking for the Coast Guard. He just has really good internet, so and his own server box and stuff.
Oh.
So, yeah.
Did you lose any of the thing in that fire in France?
Say again?
You know
No. We were my friends did. We did not. No, none of that. Because most of our stuff is like separated. It's like most of the game servers are in Virginia on my friend's box, and then the rest of like the web stuff is on a box at my other friend's house, who also does like networking in Michigan, like Sault Ste. Marie, like Michigan area. So
Cool.
we got off of having to pay like crap tons of money for that hosting a while ago once everything kind of died.
Yeah, maybe when the computer science department here gets our own server, maybe we can host a Minecraft server on it. That could be kind of fun. I don't know if the department would approve it though.
Could yeah, that would be really easy to do actually.
Well, it
This is
depends
what,
because the firewalls can be set up to block outgoing connections. I don't know if you need outgoing connections at all, or if people can just connect to it.
We could like try to sneak it through a port that's already open.
No, probably not. It's outgoing connections. So it'll accept connections, and so if you connect to it via SSH, but outgoing connections are going to be limited to GitHub, like by IP address, right? We're going to have a whitelist, not a blacklist. We're going to have a whitelist.
I see.
So there's going to be like 5 IP addresses that you could actually connect to out of like Ubuntu's update servers, GitHub, and that's going to be at the district level because they are worried about.
Are you telling me none of my GitLab stuff?
I guess GitLab will be allowed as well.
I mean, GitLab is specific to,
right,
GitLab is like GitHub, but you host it yourself.
Right. You're right. And I was thinking of what was the other one? No, there's GitLab.com, right?
Yeah, but I think you just. Oh, shoot. GitLab. LitLab? Ooh, LitLab is a thing.
Literature of GitHub.
I think it's.
Yeah, GitLab.
I don't think they host anything besides the download, though.
Okay.
Yeah.
Yeah, GitHub. I'm worried about because Microsoft owns it now, and
yes.
And they did things like they've done some kind of shady things already with it. So.
Well, thank God Discord dismissed.
Yeah.
Microsoft.
Yeah,
so
there's
fine.
huge outrage over that. I don't know if I'd be strong enough. Like if they offered me $10 billion. I don't know.
I don't know, man.
I don't know. My principals go up to about $500 million, maybe.
But 20 times that.
20
That's
times
maybe.
that. Yeah.
That might be the breaking point.
Yeah, I don't know. I might just open source Discord. Make your own.
Yeah.
I don't know. That's a tough one. It's like you can't even blame the GitHub people because Microsoft offered them so much money. It's like, okay. All right, so yeah, it looks cool. So you've got like a containerized server management.
Yeah, it's all Dockerized.
And then you can type into the console of the Docker. Is that how it works? It's like reading and writing to standard in and standard out.
This one, I don't know how to. I don't think this one takes anything because this is a Discord bot. This is our Discord bot that we set up that it syncs you can sync your Minecraft account in the game to your Discord account on our Discord server, and your rank in the game on the permission system reflects what your rank in the Discord is.
Nice.
That's why these titles, it's like mod dev is tied to this ID because these are Discord rank IDs.
Gotcha.
Stuff like that.
But like when you've got your Minecraft server open there, whatever you type in on this website gets piped to the standard in of the Minecraft server.
I typed this in.
Yeah. That's cool. That's really cool. Yeah, and so if you wanted to do something like that for Unreal Engine, I'm pretty. I can't be sure like if they would accept it, but I think they really need something like that, right?
They need something bad because it's like I had to spend probably 45 minutes finding any information that was actually usable to like discern where I would have to start with that.
Yeah.
Because especially when the most recommended thing is like just make a third-party software for it. And it's like that's not a viable solution in a lot of. Especially if you're trying to do something networked that spins up and spins down by itself. Yeah. It's
not like CN and Cout are new.
Yeah, it's not. So this is the server plugin that we were going to try to use because at the very least it looks like it has console input stuff.
Yeah. Okay.
And I was going to try to iterate on this, but the last time it was updated
was 5 years ago. It's fair.
Yeah, it was initially made 5 years ago. So.
Okay. All right, so let me. Well done, you guys. Round of applause in chat for them. That looks good. It's really I like your guys' stuff as well. Looks like full points for everybody. Prado. Okay.
And Logan's in a car off to Oregon right now, so he couldn't help. I don't know. It's something about his nephew or something. I don't know.
It's like, I'm in Idaho. Like,
yeah, he's just constantly like, I went to Oregon. I went to Idaho.
It's pandemic, man. It's so weird.
It's impossible to like get people together on things. It's stupid pandemic.
That's why in CSI 45 this semester I didn't even bother doing projects. It was just like last year when people were all in town and they knew each other and had been working together, they still couldn't get the projects done. So.
Yeah, I can't even get ACM people to do things. It's like
right.
Like when it's volunteer, 2 when it's like we lose our not being able to be in person. We lose our advantage of being the club is having access to all the computers and the resources. Right? It's like without that, it's like okay, well, what are we? We're gonna like wave at each other on a webcam for a little bit. Like I can't see your screen a lot of the times. Yeah. I don't know how to help you as a student type thing.
So, have you guys heard the news about CSUs and UCs? They're going to require mandatory vaccines to go back to school. Did you guys hear that? It was announced.
Don't tell Brig.
Like today or yesterday. So that, who knows? If they do that, there's a pretty good chance that we will follow in those footsteps. Let's see, public. So what I wanted to go over today was it's the best way of putting it. Like I guess physics. Ooh, shoot. Wait, no, bad. Copy, public, physics. Wrong server. Let's try that again. Okay. So, all right. So them. This one movement.cc. Public radix sort.cc. And make it world readable. Okay. All right, so if you're going to do physics in a game world, how do you do it? This is kind of what I wanted to talk about today. So physics is one of those like eternal problems that doesn't have like a perfect solution, but there's different approaches that have been taken over the years. So how do you do that? How do you do physics? How do you do collision? Right. So for collision, what you can do is you can do something like this. I'm going to write pseudocode, so COC is going to complain at me. Right, so you can say for every, it's like, yeah, these are physics engine. You say something like this. For every object in the world, right, let's say you've got a vector that's got every, actor in the world, right? And I know you're going to complain at me. Whatever, I don't care. So for every actor in the world, you can say like x dot move, and that might update its position. Right, so the move function might say position plus equals velocity, right? If you have a velocity of moving 5 per second, then your position would update by 5, scaled by frames per second, obviously. Trouble is, what if you've got a wall, right? You got a ball moving towards a wall, and it just teleports to the other side of the wall, right? That's not good. And you could even do something like this and say like, if x dot colliding, or something like that, or like, if it's colliding with something else, resolve it. But it really just doesn't work very well, because what happens is when things start moving quickly enough, they can actually move far enough in one frame to get to the other side of an object, and they'll pass right through it without colliding. It's very weird to be playing racquetball, and then every once in a while the ball just goes through the wall, right? That does not feel good. It's not a good feel. And so what you need is some sort of projection system, right? Like what we were talking about. Yeah, think, right? You need some sort of projection system where you actually take...
Does it smell like pumpkin spice in here?
Pumpkin spice. It's chai, my daughter. It's chai spice.
Okay.
So what you need to do is actually, when you do the collision, to project the object forwards in space based on how far it's moving. See if that is entirely open, and if it is, then allow it to move. And so rather than doing... And I've written games this way, and they don't work very well, trust me. So what you want to do is say like projection P is equal to x dot project move, something like that. Again, this pseudocode, it's going to yell at me. I don't care. So like, let's say you have a tennis ball, and we're at 30 frames a second. It's supposed to move 30 meters in a second, so it'll move 1 meter this second. If it's moving 30 this frame. So if it's moving 30 meters a second, we got 30 frames a second, then it should move 1 meter this frame. And so this would create a projection of 1 meter ahead of us. And depending on how you do this, you can do it quite quickly if you just do like a... if it's a tennis ball, you would do a cylinder, right? You take a cylinder because it's a circle and you slide it forward, see if it's open. But what you might do is you might do a rough projection where like you just have a rectangular prism. So you have a bounding box, right? So you've got a bounding box is a rectangular prism that encompasses your object, whatever it is. Like if you had a chai tea here, it'd be a square kind of surrounding the whole thing. And so it's actually quite easy to project a rectangular prism forward in space, right? You just scale it, right? You just take it and scale it in whatever direction it's going to be moving in. And then you say if world dot intersect P, ignoring X is true, then you might do like a detailed intersection if you want, or if not, not. Because like if you have one of these things and one of these things, they could feasibly fly past each other. Even though their bounding boxes are going to touch, they could still feasibly fly past. And so maybe you do a higher precision intersection test if the rough one is, if it returns true. You can do a detailed intersection. But otherwise, if it's open, you would just, then you would say x.move, right? And so what you do is you see if the spots are open ahead of you. If your bounding box doesn't hit anything, then congratulations, you know that it's open. And most of the time, that's fast and it's easy. And so as the thing's moving around, you just project a little bit ahead, intersect it with the world. Again, you need a data structure here that is capable of doing that really quickly, right? You need a data structure that can tell if there is something there in this area, like in order in login time, or login time rather, for one test, right? And there's several ways of doing that. We've talked about those before. You can do a hash table where each chunk of the world has its own cell. You can do binary space partitions. You can do essentially binary tree lookup, things like that. There's a lot of bounding volume hierarchies. There's a lot of ways of doing this. So what happens if it does something, right? So we do a detailed intersection, world.detailed intersection. So if it hits something, then what do? Then we should call then we need to call a collide function. And so in Quake C, it's called a touch function. So we call other.touch. We call x.touch. Right? And then if x's move type is equal to move bounce, then you can do like physics bouncing. So there's different physics types, right? So like for a ball, they reflect off surfaces. You can do a reflection really easy when you know the matrix math and things like that. If you have a horizontal plane, and you reflect off of it, then the y component gets set to the negative of the y component. So to reflect off the x line, you just set the y to be the negative of the y velocity, and that's it. And if your thing isn't aligned to an axis, you just rotate both of them so that it's aligned to an axis, do the reflection, then rotate it back. Easy. So you can have different types of movements. So some things, when they hit, they'll just splat. Some things, when they hit, they bounce. You should have support for all of these things if you're making a game engine. If it doesn't bounce, then x dot velocity equals, bring it to a stop or something like that. So yeah, but this is kind of the key thing here, right? So like when one thing hits another thing, you call the touch function on it. If the touch function is null, you don't. But that's how this is like our physics engine, right? So our physics engine will call callbacks. We've talked before about callbacks, right? You can have a function pointer on an object. And so if it's set to null, you just don't call it. If it's set to something, then you call it every time you hit something. And then that thing gets called and says, oh, I hit. And you'd pass in. You pass into the other person you hit, right? And then you can have very complicated and very interesting logic, right? Like if a player touches a demon, and the demon's sleeping, the demon wakes up, like, whoa, what was that? If you touch a mine, the mine explodes. If you touch a sentry gun, it electrocutes you. In my game, by default, the touch function on a sentry gun doesn't do anything. But if you touch it, if you run into an enemy sentry gun, you actually explode. I did that to make sentry guns a little bit better. Because sometimes you can move so fast that the sentry gun, which only wakes up once every third of a second or so to look around, it kind of rotates like this and kind of wakes up every third of a second, see if there's anybody there. If somebody moves fast enough, they can actually fly right past the sentry gun and things like, oh, I didn't see anything. And so I added in a touch function so that if a scout tries squeezing past a sentry gun in a corridor, they just explode. And that made that kind of covered for the slow update speed of the AI, because I don't want to load the server very much. So I'm always very cautious about running expensive computations and things like that. So, yeah, and if you wanted, you can add a think function in there. So, for every object, if x dot next think is less than or equal to current time, then call x dot think. You can do that there if you want. I would probably put that into a heap and separate from the physics engine. Just check to see who the next person to think is and call it. So that would be a little bit faster, optimal. But, use my physics engine, easy think. Yeah, okay. So yeah, so that's kind of how a physics engine works. Yeah, we probably simplify this logic a little bit, but you guys get the idea. Okay. Probably, let's see, else if, no, if, yeah, whatever, doesn't matter. And so move is just going to do things like, say, position or location or origin, whatever you're going to call it, plus equals velocity times delta. Right, so I just, whatever your velocity is times the delta amount of time since the last frame. And there you go. There's a decent physics engine. This is, of course, the tricky bit. So you have to take your bounding box and extend it in whatever direction you're moving, right? Times the velocity of delta t. You figure out how far you're going to move, and you just extend your bounding box in that direction and see if it intersects anything. And so this is a complicated thing. That's a data structure lookup, and that's a projection. And that's even more complicated because you're going to be talking about like a whole intersection. For every point, maybe in one object, you see if it's inside the whole of the other object. And so that could be quite expensive, right? But you'd only do that if the bounding boxes are like on top of each other. So you don't have to do that very often. You don't have to do it at all if you want. You can, like, it's quite common to just only use the bounding boxes. And so if you try shooting somebody in Quake right here, it hits their head. Because in Quake, they're just a bounding box. And so the people are actually rectangles. So if somebody's like trying to stick their head out around a corner, you can actually shoot past their ear and headshot them because they're a bounding box. So, yeah. Pro move right there. So yeah, it's actually quite fast to do bounding box intersection testings. We've done that before, right? You just check the X, Y, and Z on both of them and see if they overlap. It's very easy. And if they're rotated, you actually even don't allow bounding boxes to be rotated, but they're usually aligned to the world axes, X, Y, and Z. But if the thing's moving at an angle, then what you do is you rotate the world essentially so that the movement of it is along the x-axis, and then you just do a very simple box that's like this, and then everything else gets all the people in the area get translated by that rotation matrix, and you check to see if they intersect. So, but then you're not going to have world aligned boxes anymore, so it gets a little bit more complicated, but it's not that much more complicated. There's a little bit of trig that gets thrown in there, but it's still pretty easy. Okay, any questions about this, guys? I saw a cool video earlier on falling sand. I might do that for you. I don't know. You guys want to see it? Do you guys understand, first of all, this? Like, this is all pseudocode. This isn't real code. But that's more or less how I would go about doing a physics engine these days. Yeah, okay. All right. I'll delete this. It's on YouTube. It'll be up for posterity. Don't just move. Don't just, the point here is don't just move. Don't teleport things every frame. You need to... some people do it by just moving it 0.1 centimeters at a time and doing the collision over and over again. Is there going to be homework this week? Work on your project. Work on your project. That's your homework. Yeah. All right, so let's do this. Int. I love good documentation. Okay. So, what are you complaining about? Yes. Okay, so we are going to make a vector of chars. A vector of chars. And world of size. Rows and columns. Okay, so this is going to make a 2D array with one spot for each person on the screen. I might want to subtract one, I don't know, but okay. Let's pull that down by 1, because sometimes when you draw on the bottom row of the screen, the terminal scrolls up. So making it a little bit smaller is actually okay. Yeah. So Prado do projection. Okay. Okay. So what do we want to do here? While true. So let's say 10 frames a second. So you sleep, what would that be? 100,000. Okay, 10 frames a second it is. So our game is going to run at 10 frames a second, and we can change that if we want. So let's fill this with spaces, I guess, for int size ti equals 0, I is less than rows I plus plus, for size tj equals 0. J is less than columns, j plus plus, world dot at I dot at j equals space. Okay. No. Okay. Good. All right, so into a world, we will pass in world to it. So we need a function, void, into a world, taking in a vector of vector of chars named world by reference. Okay. So we need to clear screen. Okay. And let's see here. World.at5.at10 is equal to x. So we got this. Now we're going to do physics. If any of you guys need to bail out, you're welcome to. You can pick this up later. But I'm just going to build a really simple physics engine. I'll just have what I'm going to do. I could do mouse input. I could do key input. Nah, I'll just make it random. Okay. So add to world. So we will just randomly add stuff to the world at the top. 1, 2, 3, 4, 6, 7, 8. The world doesn't exist, die, I guess. All right, so we're going to go for every column. Every frame will have a 1% chance of dropping an object there. So this will just randomly put things in the top row. And it's in C standard library. Okay, so you can see it's randomly adding things to the top row over time. That sounds about right to me. All right, cool. So now we need to do physics. The world. You guys see how this works? Build a little bit of time, build a little bit of time, build a little bit of time. Always running your code, always testing, compiling, making sure it works. Yes, no? You guys still here? Okay. Okay, so for every spot in the world, we're now going to do physics. If that spot world.at is equal to empty space, we will move on to the next spot. All right. So we're going to ignore all the empty space. If we wanted to optimize this, we would keep a vector of all the objects in the world, like I had in my previous example. Right now, we're just going to skim over the entire screen every time. Yeah, it'll work for now. Okay. I'm indeed in the realm of the living. Yes, good. Okay, so, but if, however, it is an x.at I.at j equals sand, so no magics, no magic words. So if the spot is sand, now we need to do something. So by default, it should just move down one square. So if the row below us, if world.at I plus 1, and Muya, what's the problem with this? .at j equals open. Harlan, Prado, what's the problem with doing this?
Out of bounds. I thought my mic was unmuted, but it wasn't.
That one, yeah. So we need to make sure we're not on the bottom, right? So do we even need to simulate it on the bottom? Nah.
Imagine not simulating acceleration.
No, I'm not going to do acceleration because I don't want to deal with the teleportation thing. Because then you have to do that projection thing that I talked about, and nah, not going to do that right now. It's similar to your code actually for doing the line, Muya, that you were showing me last night, where you go one square at a time and you see what squares you should go to. So if the sand is going to move from here to here, you have to do that for loop and go through every point along the way, computing dx, dy, blah, blah, blah. See if all of them are open. If all of them are open, it moves. If not, it moves as far as it can. I don't want to worry about that right now. We're just going to move one cell per frame. All right. So if the row below us is open, I'm just not going to simulate I'm just not going to do physics on the bottom row. Easiest solution. Because they can't move down anymore, so who cares? Then world.at I plus 1, so the row below us now has sand in it. And our position, world.at I.at j, is open. It's falling very quickly. Oh no, it's because we go across one row and then immediately moves down. Then the next sweep across, we're actually moving it again, so we don't actually get a chance to see it falling, because in one loop it drops it the whole way. So this is the point at which I would normally create a struct, So I'm going to do that so it can only move once per frame. And then after the thing is over, if world.at_i.at_j is equal to moved, sand world.at_i.at_j is equal to sand. Do you guys see that? So I move it down once and then I flag it so it can't be moved again. So it can only move one. Right now it's just dropping to the bottom in one frame. There we go. All right. What do you guys think? Okay, but sand will scatter sideways if it can. It won't form a column like that. This would be fine for rock, but it's not fine for sand. So we need to make it a little more complicated.
We can visually test how good Rand is.
That's true. That's true. Yeah, that's actually a histogram for the Rand function, right? That's true. That's true. You'd have to run it for a while, though. Huh? Okay, so if that is available, okay, so if it's not available, if the spot available is not available, then bool left is equal to rand modulus 2. So we'll flip a coin and see, should we go down to the left, should we go down to the right? Okay.
You also have to check if the spot to the left and right are free.
Right. So, but it's just like which one we check first, right?
Okay.
Let's see if we can do this copy and pasting code. Yeah, whatever. Okay, if left, then we're going to check left first. So if world.at row below us dot at column to the left. Bool left open is equal to true. Right open is equal to true. So if we're on the left column, we can't move down into the left. So we would say, so if j is equal to 0, left open is equal to false. If j is equal to, yeah, I'll post the code at the end. It should be fun for you. If j is equal to world.at 0.size minus 1, then right open is equal to false. Else if world.at I plus 1, the row below us, dot at j minus 1 is not equal to open. Playing D server crashed 5 times, cool. Then left open is equal to false. And if we're on the right side, if world.at row below, column to the right is not open, then right open is false. Okay. So basically, if left open and right open, so if they're both open, then we'll just pick one randomly. If rand modulus 2 is true, then left open equals false. else right open equals false. So if we could scatter either down left or down right, we just pick one randomly. That's what all this rigmarole is for. Okay, so then we only have one. Okay, so if neither of them are open, if not left open and not right open, then we just continue, check the next spot. Otherwise, if left open, then we say the spot one row below us and one column left has sand in it now. Our spot is open. Otherwise, the spot down right of us has sand in it, and our spot is open. And that should do it. Okay, let's see how this works out. Aha! See that? See, watch when it hits on an edge. It'll scatter either one way or the other. Is this going to be on the YouTube video? My YouTube video. Yeah, yeah, sure. So that is a very simple physics engine for doing sand. And, yeah. And so I could probably increase the frame rate to make it a little more interesting. But you can see like heaps of sand are kind of piling up. But they can't pile up at more than a 45-degree angle. Then it'll scatter. You see the flickering because I'm clearing and redrawing the screen every time. I wonder what will happen when it hits the top. Huh. Okay. And then if we wanted to do water, then we would just move left or right. If left or right are open, and then we scatter left or right as well. And that would be it. Okay. So yeah, so that's a pretty simple physics engine for sand. Do you guys understand the principle? Like basically every and we can add gravity, we could add solid objects to the world. Maybe we could. Let's do that right now. If world.at so if I is greater than 20 and I is less than 30 and j is greater than 20 and j is less than 30, we'll make it solid. So solid things don't move, I guess. I don't know. Maybe I should come up with a better name than that. But okay, let's try that. Let's put it up more in the middle, maybe. Maybe a little bit further to the right. Okay. So sand will pile up on that rock there. And then it'll fall off the sides. See that? Kind of cool. It's kind of cool. I could add mouse support to it so I can click and drag. Yeah, it's like snow falling, right? I can click and drag to add, you know, obstacles and yeah, there you go. So we got a pile. I think that's the max sand that we could have here, because anything else is going to slide off. Yeah. You can see the little shadow down here. All right, so that's it for today, guys. I just thought you might enjoy that, but the real learning point for today was just kind of how physics engines make this a wallpaper engine. It could probably was.
Kearney, your mic broke again.
Gotta love these high quality blue microphones. Yeah. So anyway, the learning point for today is how physics engines work, right? And so this is a very simple one here, but you can see it works out pretty well. And it depends on the needs of your game, and you know, in reality, it would need to scale based on the frame rate. It would need to have gravity accelerate as it falls further. And that would involve having to do that projection where you'd see the route that the thing would move and move to the last available spot in that route, which would add a little bit more complexity. It's not hard, it'd just be a little annoying to do. Basically the same as the code we wrote before to draw a line. But even with some pretty simple rules, you can get really nice effects out of it. So you could add mouse support, keyboard support. It'd be kind of fun to have a guy running around jumping on it, you know, trying to get from the left side to the right side. Yeah. But you can see these things aren't really that bad once you kind of understand the theory. You can code up something really fast, you know. Yeah. So physics are one of those things that's really hard to do perfectly well. There's almost always going to be physics bugs of some sort in a game, just because, you know, when your physics engine updates 10 times a second, there's going to be aliasing artifacts from that. In this case, if something, like if you have two snowflakes on top of each other, the top one tries moving first and it'll bounce off the bottom one, and so the bottom one will move but the top one won't. Right? That's a bug in this. You don't see it because it happens right at the top layer, and so it'll be like the snowflake will appear and hover there for a frame before it starts falling, and you probably won't even notice it, honestly. And so you kind of have to think about how much realism you want. A big issue that I had with my physics engine was I wanted collision to work accurately, and solving like interpenetration issues where like you've got a random thing sticking out of a thing and then it moves through the bounding box of something else. I would get super offended by it and waste all my time trying to, you know, make these really complicated collision things, when in reality, like if you just look at how most video games work, they don't care. They have a bounding box, and if things are sticking out of the bounding box, sure, they're going to go right through that bookshelf, you know, and they don't care. And they just let the clipping make your gun vanish when it goes inside of the bookshelf. And gamers are just sort of used to it, you know, like we don't even call it a bug usually these days. Although we do kind of make fun of Bethesda, you know, for their clipping issues. That's cool. Created a little shadow here. Okay, that's it for today, guys. Working your projects. If you haven't done projection yet, make sure you do projection. Hopefully the theory I showed you earlier is enough for you. Basically, if you have a triangle on the screen, you just divide it by its distance, and that will give you a 90-degree field of view projection thing. You know, start near clip anything nearer than a meter or 1 unit, clip it away. Anything further away than whatever 100, clip it away. Everything else, its x and y location. Center of the screen 0, 0. Its x and y location get divided by its distance. That's a 90-degree field of view, and you're done. That's literally your assignment. And so if you have a triangle, it's just 3 lines. It'll shrink as it gets further away. it'll just shrink. That's it. So hope you guys had fun today, and I'm very impressed by your projects, and I want to see more. Keep up the good work. All right. See you guys.